estimating limit values from the graphs. Now, in the previous video, I told you about this approaching a value from the left side and approaching a value from the right side. So when we approach a value from the left side, that is called the left-hand limit, LHL. It stands for left-hand limit. And when we approach a value from the right side, well then, yeah, you guessed it, it's called the right-hand limit, RHL. Okay, and the limit of a function at a certain value when x is approaching to, let's say, a, okay, this will be equal to L if and only if the left-hand limit is equal to the right-hand limit. Okay, so in this case, in this example, we had this function and x was approaching to 1. Okay, so we saw that when x was approaching to 1 from the left side, then f of x approached to 0.5, right? And also when x approached to 1 from the right side, even then f of x approached to 0.5, right? So here the left-hand limit was 0.5 and even the right-hand limit was also 0.5. So in this case, we can say that the function will approach to 0.5, right? So in this case, the limit value is 0.5, okay? Now we will see, so this was the concept of the left-hand limit and right-hand limit. So again, I'll just say that, so limit of a function when x is approaching to a certain value, okay, this will be equal to L, okay, if and only if the left-hand limit, so I'm going to write this in limit notation. So left-hand limit means when x approaches to a from the left side is equal to the right-hand limit. So when x approaches to a from the right side, and both of these values are equal to L. Okay. Now we will, in this section 1.3, we will see how do we estimate the limits from the graph of a function. So first we'll understand this. I have taken 3 graphs, 3 cases. So first we'll understand the concept and then we'll do one example. Okay, so here you can see the graph in blue color and we have 3 cases. Okay, and let's say that this is the graph and let's say that this is the graph of f of x. So this is a function f of x in blue color. And what we are interested in is finding out the limit of this function when x approaches to a. Again, remember, x is just approaching to a. This notation means that x is getting closer and closer to a. It is not becoming equal to a. Okay, so in the first case, I'm going to zoom in. So when x is approaching to a from the left side, the function is approaching to this value, which is L. And when x is approaching to a from the left side, then the function is approaching to, again, this value, which is L. So in the first case, the limit of f of x when x is approaching to a is L because it's the same from both the sides. Okay, now in the second case, what is happening now? Here, as x is approaching to a, what is happening to the graph of the function? So when we are approaching to a from the left side, the graph is again approaching to this value, whatever is this value is again L. See, the value of the function at a is a different thing. The value of the function at a, f of a, when x is exactly equal to a, that value is this dot, whatever is this. Let's just say that this value is m. Okay, so value of the function at a is m. Okay, but that's not the limit of the function. Limit means that f of x is approaching to what number as x is approaching to a. So from the left hand side, f of f is approaching to L, and as x approaches to a from the right side, again the function is again approaching to L. Okay, okay, now what is the difference here? See, again, the limit here, the limit is limit as x approaches to a is still L, But the difference here is that the function is not defined at a here. In the first case, the function was defined at a. In the second case, although the function is not defined at a, but still the limit exists at a. Okay. Now, function is, okay, I'm wrong. Function is defined at a, but it has a different value at a. Its value is not equal to L. It has a different value at a. This is the difference. Now, in the third case, the function is not defined at a at all. Okay. The function is not defined at a. See, in the second case, it was defined at a, but its value was m. Its value was this number. Okay. In the third case, it is not defined at all, but still its limit will be L. When x approaches to a, its limit will be still L, because again, you have to see that to what value f of x approaches as x approaches to a. So from the left-hand side, as x approaches to a, f of x is approaching to L. And from the right-hand side, also, f of x is approaching to L. Okay, so I hope you understood the difference between these three cases. So let's take an example. So here we have a weird function, and we are interested in finding out the following limit. So we will find out limit of this function. Let's just call it f of x. So we are interested in finding out limit of f of x. So you see, we have 2 points where, the graph is having a jump. First, when x is equal to 2, at x equals to 2, there is a jump, and at x equals to 3, there is a jump. Okay, so we will try to find out the limit of this function when x approaches to 2 from the left side, then limit of this function when x approaches to 2 from the right side, and then the limit of this function at x equals to 2. Then we will also find out the limit of this function when x approaches to 3 from the left side. Limit of this function, you can skip this part where I'm writing. So x approaches to 3 from the right side, and then finally limit of this function when x approaches to 3. Okay, let's see. So when x is approaching to 2 from the left side, and let's just say that this point is 1, and this point is 2, and at this point we have 3. Okay. Now, when x is approaching to 2 from the left side, the graph of f of x is here. Okay. So the graph is approaching to this value, which is 3. Okay. So when x is approaching to 2 from the left side, the function, now you don't have to look here, because here you don't have, so when you're approaching to 2 from the left side, that means x is 1.9999999. Okay, so you have to look at the graph of the function from the left side of 2, not from the right side. Okay, so that's why you look from here, and the limit is 3 when you're approaching from the left side. Okay, so the left-hand limit when x approaches to 2 is 3, everybody. Not b, but 3. Okay, now what happens when we approach from the right side? So now I'm approaching from the right side. When x is approaching to 2 from right side, that means when x is equal to 2.00001. Now for the right side, you don't have a graph here. You don't have a graph here, but the graph is here. Okay, so right side, the function is approaching to this value. Okay, which is very close to 1. It is approaching to 1. It is approaching to 1. Okay, so the limit is 1. From the right side, the limit is 1. Now see, the left-hand limit was 3 and the right-hand limit was 1. Okay, so in this case, the two limits are not same, right? These are not same. So we say that the limit does not exist. So limit when x is approaching to 2 does not exist, because the left-hand limit and the right-hand limit are not same. Now let's look at 3. What is happening when x is equal to 3? So from the left-hand side, so when you approach 3 from the left-hand side, that means when values of x are very close to 3, like 2.99999. Okay, so from here, 2.99999 function is here. So this is very close to 2. Okay, very close to 2. So this is 2. And when we're approaching to 3 from the right side, that means when value of x, let's just take 3.000001. So the function is again approaching to this value, this value. Again, this is a number which is very close to 2. This time is 2.00001. So this is again equals to 2. Now this time the left hand limit and right hand limit are both equal. Okay, so the limit of the function when x approaches to 3 will be 2. Okay, now you would say that what is the role of this dot? Well, the role of this dot will come later when we'll study continuity. For now, just understand that this dot means that the value of the function at 3 is this, which is 3. Okay, it does not have much role in limits yet, but it will have a role when we do continuity. So I hope you understand how to evaluate limits from the graphs. If you still have any doubts, then feel free to reach out to me or comment down below.